Question 233. The mean value theorem guarantees the existence of a special point on the graph of f between these 2 points. What is the coordinate of this point? Okay, the conditions for the mean value theorem is that the given function has to be continuous on closed interval from 0 to 2, and it has to be differentiable on open interval from 0 to 2, right? Now let's look at the graph of f. So we're gonna draw this function f roughly. Here's x-axis, here's the y-axis, and it'll look like that, right? So when x is 0, the y is 3. When x is 2, let's say here is 2, the y value is equal to 5. So let's say this is equal to 5. Okay. The mean value theorem guarantees that there must exist at least one value c in the interval from here to here, such that the slope of this second line, is equal to the slope of tangent line. So in this parabola, we'll have tangent line somewhere here, right? So this, let's say this is value c. So we must have one value, at least one value c between these two x values, such that slope of this second line is equal to slope of this tangent line. Does that make sense? Slope of this second line is equal to y2. Let's say f of 2. That's y2 minus y1, f of 0 over x2 minus x1, 2 minus 0, right? F of 2 is equal to 5. F of 0, that's a 3. So 5 minus 3 over 2, that is equal to 2 over 2, 1, right? And slope of tangent line is equal to f prime of x. But at point C, that's f prime c, right? We have f of x here. Let's find the derivative of this function. That's 2x minus 1, right? So f prime c is equal to, instead of x, we're going to substitute c for x. So t is 2c minus 1, right? So slope of this tangent line, which is equal to this, must be equal to slope of this second line, average rate, 1, right? So we're going to let 2c minus 1 is equal to 1. Then 2c is equal to 2, then c is equal to 1, right? So this value must be equal to 1. And when x is equal to 1, what is the y value right here? When x is equal to 1, y value, the function value, is equal to 1 squared minus 1 plus 3. So it is equal to 3. So the coordinate of this point is 1, 3. So the answer has to be B. Question 237. The function g is continuous for closed interval from -1 to 3 and differentiable for open interval from -1 to 3. If g of -1 is equal to 3 and g of 3 is equal to 11, which of the following must be true? Okay, let's look at part 1. There exists c where c is between -1 and 3, such that g of c is equal to. Part 2, we have there exists c where on the same interval such that g prime is equal to 2, right? So let's think about this graph, the graph of the function g. G of -1 is equal to 3 and g of 3 is equal to 11, right? So we could have, here's x-axis, here's y-axis. When x is -1, y is equal to 3. So let's say here is a 3. And when x is a 3, y is 11, right? So when x is a 3, let's say here is 11. So y is 11. So we're just going to graph the function g roughly. We could have this graph, right? Function g is continuous and differentiable. So far so good? So let's check the part A, if this is true. It says that there exists c. C is between -1 and 3. -1 and 3. Such that function value g of c is equal to, right? Well, actually, this statement has to do with the intermediate value theorem, right? In order to have c between these two x values, the function value must be between 3 and 11, right? It has to be between these two function values, right? So first one is not true. Does that make sense? If g of c is not 2, but let's say this is 5, then this is true, right? Because if a function value is 5, which is between 3 and 11, then let's say 5 is here, then there exists c between -1 and 3 such that g of c is equal to 5, right? But since 2 is not between 3 and 11, this is not true. So this is false, okay? Now let's look at part 2. There exists c where c is between -1 and 3 such that g prime is equal to. Well, this statement has to do with the mean value theorem, right? When the function g is continuous and differentiable, then we can apply the mean value theorem, and the mean value theorem guarantees that slope of this secant line is equal to slope of tangent line at some value x, and that x has to be between -1 and 3, right? So let's find the slope of a secant line. We're going to draw secant line using ruler. So hang on 1 second. Okay, so that's our secant line, and slope of the secant line, y2 minus y1. So 11 minus y1 3 over x2 minus x1, 3 minus -1, right? So this is 8 over 4, which is equal to 2, right? So slope of this secant line is 2. And there must exist tangent line at some point between -1 and 3. Let's say it looks like it has to be somewhere here, right? This is our tangent line. And this tangent line, slope of this tangent line is equal to 2, right? Because they're parallel. So this c must exist between -1 and 3. Well, actually, there's one more tangent line here, somewhere here, right? So this value is also equal to c between -1 and 3, right? So we have 2 points c between -1 and 3. So this is true, right? So this is true. So the answer has to be B, right? Question 241. Let f be the function given by this. For what values of x in the interval from 0 to 3 does the average rate of change of f over that interval equal the instantaneous rate of change of f? The average rate of change of f on this interval is equal to f of 3 minus f of 0 over 3 minus 0, right? y2 minus y1 over x2 minus x1. That's the average rate of change on the interval from 0 to 3. Let's find f of 3 first. So f of 3 is equal to 3 cubed minus 2 times 3 squared minus 5 times 3 plus 6. So that's 27. 2 times 9, 18. 5 times 3, 15, plus 6. So 27 plus 6, that's 33. 18, 15, that's minus 33. So that is equal to 0. Right? What about f of 0? F of 0 is, if we substitute 0 for x, then that's going to be equal to 6. Right? So our average rate is equal to 0 minus 6 over 3, which is equal to negative 2. Right? Now let's find the instantaneous rate of change of f. That's just f prime, right? So f prime of x is equal to 3x squared minus 4x minus 5. Right? And we are looking for the values that the average rate of change of f is equal to the instantaneous rate of change. So we're gonna have to set this is equal to negative 2, right? So 3x squared minus 4x minus 5 is equal to negative 2. This is just the quadratic equation, right? So we're gonna solve this quadratic equation. Add 2 each side, so minus 3 is equal to 0. This quadratic equation is not factorable, so we're gonna have to use quadratic formula, right? So quadratic formula, x is equal to negative b plus minus root b squared minus 4 times a times c over 2a, right? 2 times 3. So that is equal to, let's say this is a positive 4 plus or minus. Let's simplify inside of the radical right here. 16 plus 4 times 9, 36. That's a 52, right? So root 52, square root of a 52 over 6. And root 52 here, 52 is actually 4 times 13, right? So this is 2 squared. So this is going to be 4 plus minus 2 root 13 over 6. And 2 times 2, 2 times 1, 2 times 3. So our x is equal to 2 plus or minus root 13 over 3. So we found two values of x, but our x must be between these two x values. It has to be between 0 and 3, right? Because the question is to find the values of x in the interval from here to here, right? So we have 2 plus root 13 over 3. That's one value x. Well, this is our answer, right? And the other one, x is equal to 2 minus root 13 over 3. Well, 2 minus root 13, that's negative, right? This is just only root 4. This is root 13. So this is a negative number. So this cannot be the answer, right? So the answer x has to be only this, 2 plus root 13 over 3. Question 243. Suppose f is a differentiable function on the interval from negative 2 to 2. The table above gives values of f at selected values of x. Which of the following statement must be true? Here we have 4 answer choices here. And answer choice A says f prime is positive for all x in this interval. Well, that's not true, because we don't know what happens to the graph of f between these x values, these given x values, right? For example, let's say when x is 0, y is 1, right? When x is 1, here y is 2. So we have coordinate here, right? We could have strictly increasing function like that, right? Or we could have function increases like that and decrease from here. Do you guys see what I'm saying here? So we cannot conclude that f prime is positive for all x in this interval, especially from -2 to 2. We cannot conclude that f prime is always positive, right? So A is not true. What about B? B is also not true, right? We cannot conclude that f is increasing from -2 to 2, right? So that's not true. Okay, answer choice C says f prime is equal to 0 for some x in this interval. Okay, when x is -2, the function value is -5. When x is 2, the function value is also -5, right? We have the same function values, right? Here, let me draw this graph, the graph of f roughly. Here's the y-axis. Here's the x-axis. -2, here is 2. When x is -2, y is equal to -5. Here we have -5. And when x is -1, it's -3. So let's say it's somewhere here. 0, 1, 1, 2, 1, 2, somewhere here. And 2, -5. So roughly, we could have this type of graph. The function f passes through all of this point, right? Okay, this is a differentiable function, right? The slope of a secant line that passes through these 2 points is actually equal to 0, right? Slope of this is 0. It's a horizontal line, right? Then we must have tangent line between these two x values, such that the slope of the tangent line is equal to 0, right? So slope of this, which is equal to f prime, let's say C, that is equal to 0, right? So we must have for some x, we must have tangent line, and the slope of the tangent line must be equal to 0, right? This is Rolle's theorem. So C is true, right? Okay, so the answer is C. Now, answer choice D. F prime does not exist for some x in this interval. Well, that's just not true, right? Because it was given that in this problem, that function f was differentiable, right? Differentiable in this interval from -2 to 2, right? So D is not true. So the answer for this question must be C. Question 245. If f is continuous on this closed interval and differentiable on this open interval, which of the following statement is not true? Okay, answer choice A. F prime is equal to 0 for some x in this interval. Well, that's not always true, right? It's because if a function always increases or always decreases, then we don't have a tangent line that has a slope is equal to 0. Okay, let's look at this function. Here, let's say we have f of x. Looks like here's -4, here's a 0. So let's say it starts from here, it goes to here. Let's say we have this function, and this is f of x. You know, if we look at the slope, this is the slope of tangent line, right? If we look at the slope, if f function is always increasing, strictly increasing, the slope is always positive, right? There's no x value such that f prime is equal to 0 in this interval, right? So this is not always true. So the answer must be A. f prime is equal to 0 for some x only if f of negative 4 is equal to f of 0. This is Rolle's theorem, right? Okay, here, let's say when x is negative 4, the value is right here. When x is 0, the y value is the same as f of negative 4. Then, let's say we have this type of graph, increasing, decreasing, like that. Then we do have tangent line that has a slope is equal to 0, right? That x is going to be between negative 4 and 0, right? This is only true when the endpoints, the function values of at endpoints are equal to each other. Okay? Answer choice B. F prime is equal to f of 0 minus f of negative 4 over 4. This is actually average rate of change of f on this interval, right? Here, y2 minus y1 over, this is x2 minus x1, right? If we rewrite this expression, this denominator, x2 minus x1, which is equal to 4. So that's average rate, the slope of second line. That is equal to f prime, the instantaneous rate, right? Slope of tangent line. Well, this is true by mean value theorem. So B is true by mean value theorem, right? The conditions for mean value theorem, remember, it has to be continuous on closed interval and differentiable on open interval, right? So since f is continuous and differentiable on this interval, this is true by mean value theorem, all right? Okay, answer choice C. Okay, it says f has absolute minimum on this closed interval. This says f has an absolute maximum on this interval. Well, this is about extreme value theorem, right? If function is continuous on closed interval, f has an absolute minimum and absolute maximum on this closed interval, right? That's extreme value theorem. That's true, right? Okay, if we look at this function right here, this function with the black color, let's say f of x is this. Here we have absolute minimum. Here we have absolute maximum, right? If the function is this blue color, if this is f, we have absolute maximum here, we have absolute minimum here, right? So if the function is continuous on the closed interval, it has absolute minimum and absolute maximum by extreme value theorem. So these two are true. So the answer must be A.